Continuing with the OR, we'll just go with one more problem where supply and demand are not equal. So in the figure, if we see ABC are our manufacturers, W1 and W2 are our distributors, XYZ are our retailers. So when we see at the manufacturing side, the total supply is 400 plus 500 plus 700, which is 1600. And the demand side, if we see from XYZ, it is 400 plus 600 plus 500, total 1500. So there is an excess supply of 100. So how to solve it in LPP? We'll just look at it. And we have also given the weights are also given. So the weights for individual parts are also given. We'll try to construct in a matrix form. So the given part, the supply is 1600. Then the demand is 1500. Now let us construct the matrix. The sources. The source for here are A, B, C are the primary source. W1 and W2 are our secondary source. Just add the source A, B, C, W1, then W2. Then the destinations. W1 and W2 are our intermediate destinations. X, Y, Z are our final destination. Retailers. But distributor is also the intermediate destination. So W1, then W2, then X, then Y, then Z. So this is our cost matrix. One matrix is our cost matrix. One more matrix will be our variable matrix. So in the cost matrix, first when we observe the path between A and W1, from A to W1, there is a path. Cost of the path is 25. Similarly, from A to W2, the path is 38. We enter 25, 38. So with respect to X, from A to X, there is no direct path. So for R to say that to Excel, we put 1000. So that Excel doesn't take that path. Similarly, from A to Y, there is no path. Put again 1000. From A to Z, there is no path. Put 1000. Yes. Then from B. So from B to W1, 38. Then W2 is 40. 38, 40. Again, there is no direct path with XYZ. Again, 1000, 1000, 1000. Then from C, 40 and 25 are the paths. Remaining are thousands. 40, then 25. Just select it and pull it. Now from W1. So from W1 to W1, there is no path. You can put it 0 or you can also put it 1000. In the previous video, we have put it 1000. In this video, let us put it 0 and see what happens. Then from W1 to W2, there is no path. That there is no path, put it 1000 definitely. From W1 to W2, there is no path, again 1000. W2 to W2, put the cost as 0. Why putting it 0 or putting it 1000, which is better is up to you. You can put both. In the previous video, we have put 1000. This video, we are putting 0. Let us check if we are getting the answer or not. Then from W1 to XYZ, the paths are 20, 30, and again 20. This is the same 20 that way and this way. That's why the image is showing like that. This way is also 20. This way is also 20. So 20, 30, and 20. 20, 30, and 20. Then from W2, 30, 20, and 40. 30, 20, 40. Now we are ready with the entire matrix. This is our cost matrix. This is just just to visualize it in a grid way. I like to see it in grid way, so I will create. It's optional. Then we just copy it and paste it here. Because these are the same variables. The variables are the weights. What are the quantities that should travel from the different paths? Initially, they are all 0. Just extend that 0. Then extend it once more like this. Right? So here, what is the W1, W2, X, Y, and Z? These three are destinations. So for destinations, it is incoming. How much is incoming? How much is the demand? And we look it like this in a vertical way. This is incoming is nothing but the sum of whatever is coming here. Yes. So we are putting auto sum. Auto sum is also selecting this value, the 23, 22, which is not necessary. Just click here with shift down arrow. You can select all of this and click enter. then again extend it to the entire matrix row. That is extended. It is ideal to leave a column, leave a row here, because for calculations and all, we don't confuse, and always try to name this so that you know what it actually is calculating. Then here, these A, B, C, W, and W2 are your source. So that is your supply. That is supply is nothing but outgoing. As we have put incoming, then the opposite outgoing will be here. Then the outgoing should be matching with the supply. That is your constraint. Supply. So one thing, what we know about objective function. Okay, we just also do the auto sum first here. Then the auto sum, selecting all these, click here, select these cells, then just extend it. So this part is over. We'll just come back to the question once. So we know that these goods are here. They have to be manufactured to these destinations through the minimum path possible. That is your objective function. So let us construct the objective function first. So let us put it just here. Z. It is nothing but the weights which are transferred. These are the weights which are transferred into the cost. So simply it is a sum product is equal to sum product of
the matrix.
This matrix and this matrix. Enter. This is your objective function. Then let us look at the constraints. We come to the constraints. From A, whatever is outgoing, it can outgo through these two paths, either the first part or the second path. We only want it to go, it can go through any part, but how much can go? It can go only 400. Not more than 400 can cross. Less than or equal to 400. More than 400 you can't cross. More than 400 can't cross means less than or equal to 400 can cross. The opposite. Similarly for B, from these two paths, less than or equal to 500 can pass. Less than or equal to 700 per pass. But here if you see the incoming for X, it should definitely be equal to 400. Why? Demand should be met. Since supply is more here, less than or equal to is okay. Because anywhere you can put 100 can be stopped at any location. You don't know where you can stop because you don't know the path, entire path cost. So less than or equal to can pass here. But since you are putting equal to 400, Excel solver will try to satisfy the demand, but it will utilize the supply in the least path possible. So extra supply can be left at the location itself. Wherever it is having a maximum cost, it will leave the supply there. Wherever it is a minimum cost, it will try to use the entire supply.
And Excel will decide that.
Excel solver will use it. So that constraints are for X, Y, Z, the demand should be equal. And by W1 and W2, whatever is incoming, that should be equal to outgoing because W1 and W2 doesn't have any storage.
Intermediate.
They're just intermediate. They are take it and they pass it. So in the same way, so W1 and W2 are incoming here. So if they are incoming, the incoming demand should be equal to how much?
Supply.
This is, it should satisfy, this is the, what is incoming from here. The incoming should be equal to the outgoing. So that we will equate later. For X, the incoming is equal to the demand. That's why we have written demand here.
Equal to demand.
Equal to demand. So what is the demand for X? 400, 600 and 500. So 400, 600, 500. And it should equal to the demand. So equal to. We'll come back to these two again. Similarly for ABC, what is the supply? Just enter the supply first. ABC supply is 400, 500, 700. 400, 500, 700. And we have said, since supply is more, at anywhere Excel solver can stop it. But we have equated to demand. So it will extract the entire goods needed for the demand, but it will leave at any other node. We don't know which node right now.
Any part.
At any place. At any place at the manufacturing place. So we'll put less than equal to, and less than equal to. Now for W1 and W2. So whatever is incoming at W1 is equal to the outgoing at W2. Similarly, whatever is incoming at W2 is equal to the outgoing at W2. So I'll just keep it a color scheme so that it is easy to understand. So these both are equal and these both are equal. and this is your objective function. Just coloring, color is not necessary. This is just to identify, to visualize it easily. So this part is clear. We know the objective function. We have put all the constraints. We have entered all the weights. And here what we are testing, we have put W1 and W1 as 0. Why we have put it 0 and not 1000? The previous video we have put it 1000. Either way works. By putting it 1000, you are saying Excel solver not to use the path. By putting it 0, Excel solver also will not use the path. Why? Because it has to know from W1 goods have to be sent from X, Y, and Z. Why? Because the constraint is set. Whatever is incoming at W1 should be equal to the outgoing at W1. So it cannot store anything. That's why it will not use the path and proceed away. So you can put 0. Okay, we'll just see the solver. Then after solving, you will understand it much better. Data, solver, like always, reset. And here it is a cost minimization. So don't forget to put it. Then the objective function is Z. Minimize. The variables are this matrix. Always it is ideal to leave one row and one column next to matrix so that it is clear to understand the constraints. Then we'll add the constraints. These three are less than equal to these values. Add. Then these two
3
are equal to these values. Add. Then these two are equal to these two. Then okay. Then simplex LP. Now it is already there. Then solve. Excel solver found a solution. Okay. So if you see the supply, entire supply from A is used because outgoing is 400. Entire supply from B
not used.
is not used. Only 400 units are used. 100 units is left. Entire supply from C is used. 700. And if you see at here, the entire demand from A is from X is met, for Y is met, for Z is met. Whatever is coming at W1 is going out of W1. Whatever is coming at W2 is going out of W2. So this is what we understood when supply is less than demand. Supply and demand are not equal. Then where you have to put the equality sign, where you have that, don't just blindly put equal or less than equal. Understand what you have to do. Try to draw the diagram like this. If you need not mention the mates, but just put the entire supply, total supply is equal to this much, total demand is equal to this much, and then proceed to the problem. In the next video, we'll see if at all there exists a path between W1 and W2. Suppose if you want to send goods from W1 to Y, the cost is 300. But if you are having a path from W1 to W2, the cost is 8. And from W2 to Y, the cost is 20. So in the case of 28 is cheaper. So we can send it like this. We'll see how to solve it in the next video.